Hi, I'm Papia. In this problem, we are going to compute area of a region bounded by two functions. Now, the functions are given to us, f and g, and the graph of those functions are also given to us. So you can see that the region that's bounded by f and g from the graph itself. So g is the upper curve and f is the lower curve, okay, and these are the expressions. So we have to compute the area between them. Okay, so you can use definite integral to find area, as you know, that definite integral gives us area. So first we have to set up the integral and then we'll solve it. Okay, so to compute area, bounded by f and g, say you have to have an interval, of course. So inside, say, the interval AB, the setup is its integral from A to B, and then you have to write down the function here. It is the difference of these two functions. Now, you have to be careful because area is usually a positive quantity. So depending on how you write down the difference between the two functions, you can get a positive answer or a negative answer. So the best way to ensure that you will have a positive answer in the end is if your setup includes the upper curve minus the lower curve. Okay, so you have to choose what is the upper curve and what is the lower curve. And you have to write it in this order, upper minus lower. So if you notice, in this particular case, upper curve is g, which means g is actually bigger than f, right, throughout this interval. So in this particular case, we will have g minus f from A to B. Okay, so this part is set already. What we don't have yet are these limits. What is that interval that this entire region lies in? Now, if you look at the graph, you will probably see right away that it starts at 0 and it ends here, this point. And from the graph, you will see the point already, right? But what if you don't have the graph? Then how do you figure out this interval? If you notice, the intervals are exactly the points where the two curves are intersecting. So you have to compute points of intersection of the two functions. So let me show you how to do that in this particular problem. So that will be step 1. Find the points of intersection. And do you remember how to compute points of intersection? You just take the two function expression, make them equal to each other, and solve for x. So let's do that. One of the function is x squared minus 4x plus 3, and the other one is negative x squared plus 2x plus 3. Okay, you set them equal to each other, and then you have to solve for x. The best way to do it is bring everything on one side and set it equal to 0, and then you can have probably a quadratic, you can factor and all sort of things. Okay, so bring the negative x squared to the left. So you get x squared plus x squared, you'll get 2x squared. Okay, then we have a negative 4x and a negative 2x, so negative 6x, and the 3 cancels out. So this is equal to 0. Okay, so now let's see, can we factor? Well, we have a common factor of 2 from both terms and a common factor of x. So pull it out and you will be left with, from the first term an x, from the second term negative 3. That is equal to 0. So you know each factor can be set equal to 0 and that will give you the x values. So when you set this one equal to 0, you get one of the points of intersection being x equals 0. When you set this one equal to 0, you get x is equal to 3. So that gives you the interval where this region lies is between 0 and 3. Okay, so we have our A and B. So now that we have our points of intersection, let us set up the integral and then solve it, and then we'll have our area. Okay, so the integral will be from 0 to 3, those are the limits. And again, upper curve is g, so write down the expression for g, negative x squared plus 2x plus 3, and then subtract the lower curve, which is f. And f is x squared minus 4x plus 3. I strongly suggest, before you try to solve, find the antiderivative, please simplify this expression so that you do not have to deal with too many terms in the end. Okay, so let's see. There are common terms, right? X squared, they're like terms. You can combine them. So here's a negative x squared and a negative x squared. So you'll have negative 2x squared. Then you have a positive 2x and a negative of negative 4x, so positive 4x. So 4 plus 2, that's 6x. And then see the 3 minus 3 cancels. So this is the simplified expression for the function. And now we just find the antiderivative, plug in the limits, and then we'll be done. So for the first term, pull out the negative 2, and antiderivative of x squared is x cubed over 3. For the second term, pull out positive 6, that constant. Antiderivative of x is x squared over 2. And then you plug in the values 0 and 3. So let's continue. So for the first term, negative 2/3 is the constant. Now what you can do is you can consider each term separately and plug in these values for each term. So that's what I'm going to do. I'm going to take out the negative 2/3, and for x cubed, I will plug in 3. So we'll get 3 cubed minus 0 cubed. And then for the next term, 6 over 2 you can cancel. That's just 3. And for x squared, you plug in 3, which is 3 squared, then subtract and plug in 0. So the zeros you can just ignore and then combine the other terms and see what our area turns out to be. So this is negative 2/3 times 3 cubed. So 3 cubed is 27 plus 3 times 3 squared. So 3 squared is 9. 9 times 3 is 27. You can right away cancel here, 3 and 27, so that's just 9. 9 times 2 is 18, so negative 18 plus 27, and that is 9. So the area of this region that's bounded by these two functions f and g between 0 and 3, those are the points of intersection, turns out to be 9 square units. Thank you.